Given the linear functions m of x equals x minus 3 and n of x equals 3 plus x, write a polynomial for their sum m plus n of x and graph all three functions on a coordinate grid. Using the graphs, compare and contrast their critical attributes, slope, x-intercepts, y-intercepts, and point of intersection. Okay, so looking at these are three linear, and we see that m of x has a slope of 1, n of x has a slope of 1 as well, the number in front of x, and then we see the y-intercepts of 3, or 0, 3, and then 0, negative 3, and then we'll add those together as well. And so let's go ahead and just algebraically add these together. So if we want to add m of x plus n of x, we can just substitute in m of x, which is x minus 3, and n of x, 3 plus x. Adding those together, then x plus x is 2x, and negative 3 plus 3 just adds to 0. And so it'll just be 2x. So now using those facts to make a graph, then I've gone ahead and put these lines onto a graph. Okay, so first just looking at slope, we already know the slope from the equations, and that's how I graphed this as well. And so the slope for m of x, as we said before, is 1, n of x is 1, and m plus n of x is 2. And so again, that makes sense because the slope of the two different functions added together should equal the m plus n of x. And then for the y-intercepts, then we also saw those from the equations, that for m of x, then it was 0, negative 3, n of x, 0, 3, and then for m plus n of x, then it should be, from the equation we see it should be 0, 0. From the graph we see it should be 0, 0. And so it is, and that makes sense because the two other functions should add, so negative 3 plus 3 does equal 0. So that works. And then for the x-intercepts, let's point those out in the graph. So for m of x, then we have 3, 0. N of x, we have negative 3, 0. And then again, we have 0, 0. And then we can also see for the intersections that we have an intersection here at negative 3, 6. And so we just see here that at the x-intercept, we do have an intersection with the other two lines. And then at the other x-intercept at 3, 0, we see that the other two lines do intersect. And so that is a property there of these two functions being added together. And so we'll just go ahead and fill this in over here. And so again, just noting that the x-intercepts each have a point of intersection at the same x value. Also note that n of x and m of x both have the same slope and they are parallel, so those two lines will never intersect, but both intersect with m plus n of x. And so let's go ahead and summarize our answer. M plus n of x equals x minus 3 plus 3 plus x equals 2x. For the slopes, the slope of m of x equals 1, slope of n of x equals 1, and slope of m plus n of x equals 2. The slope of m plus n of x is 2, the sum of the slopes of the addend functions. Because the slopes of m of x and n of x are the same and their y-intercepts are different, their graphs are parallel and do not intersect. Y-intercepts. M of x equals 0, negative 3, n of x equals 0, 3, and m plus n of x equals 0, 0. The y-intercept of m plus n of x is the sum of the y-coordinates of the y-intercepts of the addends. X-intercepts, m of x, 3, 0, n of x, negative 3, 0, m plus n of x, 0, 0. The intersection of m of x and m plus n of x is negative 3, negative 6, and has the same x-coordinate as the x-coordinate of the x-intercept of n of x. Also, the intersection of n of x and m plus n of x, which is 3, 6, has the same x-coordinate as the x-coordinate of the x-intercept of m of x.